Okay, so the lesson for today is we are learning to go from mass to volume or volume to volume using this flow chart. It's exactly the same thing that you did for homework yesterday, except that you might be starting maybe with mass. Then if you wanted volume, you'd have to go to moles, moles to moles, moles to volume. Or you might start with volume, and then you would go from volume to moles, moles to moles, and then if they want volume, you'd go from moles to volume. But the whole point is, you would always have to use this flow chart regardless of where you're going. And you will have it memorized by the time of the test because we use it so often. Okay, now, you guys will enjoy the volume more than you did molar mass because the nice thing is that the relationship is always 22.4 liters for every 1 mole. So when we do triangle balanced equation triangle, whenever we're using the triangle and it includes liters, the conversion is always 22.4 liters to moles. So we prefer that rather than having to calculate molar mass. Let's look at the first example. Go ahead and write it down, what the given and the find is. How many grams of water can be produced from 65.93 liters of oxygen? Use the following reaction. So we have, the given is 65.93 liters of oxygen, which is O2. We're trying to find grams of water. Okay? 3-step conversion. Look, we're going from liters to mass. That means we start off here. We're going to go this direction. Okay? So, we have liters of O2. And what do we do for the very first conversion every single time? Convert to what unit? Moles. Remember that. Okay? So, moles of O2, using the triangle, what is the relationship? Anyone? It's 22.4 liters for every 1 mole. Okay? That's the first conversion. The second one, we're going to go from moles of O2 to moles of H2O. Okay, now we're here. And where do we get that information? Balanced equation. Okay, look at the relationship between the two. I have 1 mole of O2 for every 2 moles of H2O. So I'm going to put that in. Now I have moles of H2O, and I'm trying to get grams of H2O. So using the triangle, what information would I have to use? What is the conversion here? For every what? Well, it's not liters. We're doing grams now. So for grams, you would use molar mass. Looks like we're going to have to go up here. Okay? So 18. Okay? Molar mass of water, because we're converting it to grams. That's what we're trying to find. Okay? So then you set it up. You start off with what was given. Okay, you're going to do your first step conversion. Now the 22.4 liters goes on the bottom so it can cancel. And you have 1 mole on top. Plug and chug at this point, right? Okay, and then for the bottom, we want to cancel out moles of H2O. So that goes on the bottom. And 18 grams of H2O go on top. Okay, is anybody able to calculate this? Now, realize liters of O2 cancel, moles of O2 cancel, moles of H2O cancel, and you will have grams of H2O. What do we get?
This will all cancel except the 18?
Yeah, well, the units cancel. You still have to plug in the numbers. I get About 106. I don't know exactly, but make sure you get that same answer and that you do know how to plug it into the calculator. But what I want you to realize is it's exactly like yesterday, except we're using liters, and so sometimes we use a different part of the flow chart. There's all these directions we could go. What did you guys get?
105.9.
Okay, 105.9. Let's fix that. 105.9. That's a good answer. I like the 105.9. Okay, let's do the next one. We have how many liters of hydrogen are needed to completely react with 500 liters of oxygen? So we're going from liters to liters. That means liters to moles, moles to moles, moles to liters. Okay, these are my favorite because they're the easier ones. So the given is 500 liters of oxygen. The find is we're trying to find liters of hydrogen. The conversion factor, you start off with what was given. We have liters of O2, and we always convert to moles first. Using the triangle, we have 22.4 liters are equal to 1 mole. That's the relationship between liters and moles. Remember this? Okay. For the second one, we're going to go from moles of O2 to moles of H2. Using the balanced equation, you look at the relationship. There's 1 oxygen for every 2 hydrogen, so I will plug that in. The third conversion is to go from moles of H2 to liters of H2. And we would use the triangle relationship for that. It is that for every 1 mole, we have 22.4 liters. So now we can start off with what was given. You would put the first conversion factor in the first parentheses. You'd put 22.4 liters of O2 on the bottom, 1 mole of O2 on top. You look at the second conversion factor for the second parentheses. 1 mole of O2 goes on bottom, so those could cancel. 2 moles of H2 goes on top. Then 1 mole of H2 on the bottom, 22.4 liters from the third conversion factor for the third parentheses. These all cancel out, and you'll end up with liters of H2. And what do we get here? Perfect. That is the right answer. Yes. Very good. Okay. So you simply just follow the flow chart. Now, I actually think you guys have had enough practice. But what I wanted to tell you, the next one goes from liters to grams. You would simply start with liters, go to moles, moles to moles, moles to mass. Okay? If any of you want to take a picture of my last example, I have it.